All right, so this is going to be the second video on transformations. It's on reflections. It's actually one of two videos that I'm going to do on reflections. This one is mainly just to talk about the concept of the reflection, and it's all going to focus on the x-axis and the y-axis. So you're given a question. It says reflection across the x-axis. So we're going to take TUS here and reflect it across the x-axis. So what does that mean? It means that it's going to end up over here. So let's talk about some of the changes that we can see in the polygon here when it moves. One thing that stands out at me right away is that the T ends up, you see, on the opposite side. The T and the S are actually switched. So, you can see the S here and the S here. So that's sort of like what's going to happen. And that's because of the word, if you think about it, reflection. What reflection, when you think of it, you usually associate that with mirrors. So that's what's involved here as well. So we're going to be reflecting across the x-axis, which you can see what I did was I lit this up in green so that you can tell that this is going to be our mirror. In other words, the x-axis itself is the mirror, and so that's why it reflects that way, okay? The other thing about reflections, just in general, is that a reflection is going to only affect one of the coordinates. So on every ordered pair, there's an x-coordinate and a y-coordinate. What's going to change here is only one of them. So you can kind of see which one it's going to be. The S and the T do switch, as does the U, in terms of where it is in a vertical sort of context, whereas it did not move from left to right. In other words, T stayed where it was, as did S, as did U. And if you think about when you look in a mirror, yeah, if you move further away from the mirror, the U on the other side moves further away. And then when you move left and right, the U on the other side moves left and right. So what's going to happen here is we're just sort of moving away from the mirror. So the rule, in case you haven't figured it out already, the rule is that the y-coordinate is going to be the opposite of what it is. So when you see the x-axis when you're reflecting, what that means is you have an opposite y-coordinate. Now you got to be careful not to get confused here about that, because it says x-axis, so a lot of times people go, oh, reflection, it means opposite, x-axis, so opposite x. It's actually the other coordinate that changes, but you'll quickly remind yourself of that. Again, this is very visual. If you look at it, you're going to realize that like this thing would be down here somewhere, because that's the mirror. So just keep that in mind when you do it. But otherwise, if we keep this sort of like rules focused and focused on the ordered pairs, it's actually a very simple exercise to figure out where the reflected one is going to be. So in this particular case, as I stated, the x-coordinate will stay the same. So I'm basically going to copy these down because those will not change. What will change is the y-coordinate. So the y-coordinates is going to be the opposite. So this is going to be at -3. This will be at -1. And this will be a -2. And if they're negatives, you just make them positive. So you just do the opposite. So if I turn this back on and kind of check to see what I did here, you can see 0, -3 is where it's supposed to be. 3, -1, so it's 3, but now it's down at -1 instead of +1. So everything here makes sense. That's really how it works. So let's look at one where we're reflecting across the y-axis. So everything here is set up the same as we did before. So what we're going to be doing is reflecting it across the y-axis. So it's going to end up over here like this when we're finished. So how do we do that? Well, same as before. So we're going to focus on the y-axis, which means that we're going to have the opposite x. And so when we list out our changed ones, that's exactly what we're going to do. So the opposite of this is 1. The opposite of this is -3. The opposite of this is 0. In other words, it has no opposite. So if you think about a mirror, and this does happen quite frequently, is that one of the points is actually on sort of like the mirror. Okay, so in this particular case, our y-axis right here is our mirror. Right, so that being the case, if you stick your finger right up on a mirror, your finger is technically on the exact same point. It's only when you start moving away that it starts to drift to different locations. So that stays the same simply because it has no opposite, okay? Now let's sort of focus on what we are changing, or not changing in this particular case. So these all, we did change the x. So these are all going to stay the same. That one's going to be a 2, this one's going to be a -1, this one's going to be a -3. And so if we turn our answer on just to double check our math, you could see that everything is where it's supposed to be. That's at 1, 2. This guy here, the D is at -3, -1, and the B is of course in the same spot because it's actually on the mirror. And just like we had the other one, you can get different types of questions for this. Mainly it has to do with moving the shape and writing the ordered pairs, but sometimes they give you something like this and it says what happened. This is really easy to tell what happened if you just look at the R, for example. The X is the same and the Y is the opposite. So I didn't even talk about what the actual numbers are, but opposite. So this is a reflection across X. And that is all you could possibly encounter with this. So that's how you do a reflection.